All right, so let's take a look at this first example. This you do not have to copy down. You do not have to copy down. I want you to watch it, and hopefully it makes sense, and then you can do the Khan Academy assignment. But right now, let's take a look. The sum of the areas of the rectangles in the figure below approximates the area under the graph of the function 1 over x on the interval 1, whoops, you can see that, 1 to 4, right? You're told that spot. And these are actually, the top right corner is touching on all of them, yeah? So this is R, right, for the right Riemann sum, and 1, 2, 3, 4, 5, 6. So this is R6, actually. I mean, that's not asked for, but that would be R6. Like the motorcycle, like the Yamaha R6. No, okay. Which of the following is the sum of the areas of the rectangle? What does this mean? This is a summation. That's the Greek letter sigma, capital sigma, I think. I don't know. And it's talking about. I mean, it just means sum up the terms. So I'll show you what that means. But first, I want to know the actual area. I think the easiest way is just to look at the graph and calculate the areas, and then look at each one of these and see which one matches. So I'm going to calculate the areas for each rectangle. That's base times the height. How you going to know the height? Well, first you look over and like that, I don't even know. I don't even know what that is. Right? But I can get it because I'm given the equation. I'm given the function. So let's see. The base of the rectangle, that's easy to see. That's very, very simple. That's 1 to 1.5. That's definitely a distance of 0.5 or 1/2. I'm going to change it to 1/2. And same here, 1.5 to 2, that's also 1/2 and 1/2 and 1/2 and so on. So all the bases here are 1/2. Cool. That's cool. So let's see. If I had, for the first rectangle, rectangle numero uno, I would have 1/2, right, that's the base, times the height. How I get the height? Well, I know that the top right corner touches my graph. So if I were to plug in 1.5 to my function, that the y value would be given, right? Do you see this? So if I say f of 1.5, well, that would be 1 over 1.5. That's the same thing as 1 over 3 halves. Flip the second one and multiply. That's the same thing as 2/3. Okay. Right? Yeah, it's less than 1. It's 2/3. So the height would be just f of 1.5. So f of 1.5 is the height of the first rectangle. So I do the base, 1/2, times the height. Well, I wanted that, so I just plug in whatever I need. And that was 2/3. Sweet, man. And then I would have to add this rectangle, right? You know what I'm saying? So this one would also be 1/2 times the height. And here, well, if I plug in 2, right? If I plug in 2 here, I get 1/2. And that's what it shows on the graph, right? 0.5. Okay, so that's 1/2 for the second rectangle. That's 1/2 times 1/2. And then I'm going to do, well, the third rectangle. You really don't have to do this many, I don't think, but we'll see. So that's 1/2 for the base times the height. Remember, you can get the height by plugging in whichever corner touches. Like this is the right side, so I need to get the right side of that rectangle, which is 2.5, and plug it into my equation so I can find the y value, right? Because that would be the height. So what did I say? 2.5. So f of 2.5. This is long. This is extensive. 2.5. That's the same thing as 1 over was 2.5. 5 over 2. 5 over 2. 1 over 2. So that will be 2/5. You can flip the second one and multiply. 2/5. So 2 over 5 plus, and so on. Yeah, you see this? What is this? That's 1/3. Sweet. Plus 1/4. I'm just simplifying. Plus 1/5. Oh, what's the next one going to be? 1/6, of course. And so on. Okay, now, so that's just getting the area from my rectangles. Hopefully that's straightforward. Now we need to see what DC means, huh? Well, it just means we're going to do iterations. When you have sigma note, this is called sigma notation. This is a lot in one video. When you have sigma notation, it's just saying you're doing different iterations. So this one means the first time you evaluate, you're going to plug in 1 for n. So I would have the 1/2 out front. Actually, that'll be 1/2, and then I plug in stuff. Okay, so I would do, for the first iteration, n is 1. So 1/2 times 1 minus, I'm going to say 1/2, minus 0.5. So that's the first time I plug something in. The sigma, S, it's like the Greek letter, kind of like S, it means sum. So we're going to add, and then we're going to increment this by 1. How far do you think we're going to go? We're going to go all the way to 6. It's crazy, huh? So the next time I plug stuff in, I'm going to plug in 2. Well, 1/2 times 2 minus 1/2. And then I'm going to continue on. I mean, now stuff gets in the way. I would continue on the next time I plug in a 3 for n, and then a 4, and then a 5, and then a 6. I don't keep going because this is where you stop. Yeah, there we go. So what is this? This is equal to 1/2 times, that's 1 divided by 2 times 1 is 2 minus 1/2. What's 2 minus 1/2? That's 3/2, isn't it? Right? 2 minus 1/2? Yes, that's 3/2. 2 minus 1/2 is 3/2. Well, that's the same thing as, flip the second one and multiply. That's the same thing as 2/3. Right? Because 3/2, you flip it, 2/3. And then plus, well, first thing here, plug it in. This would be 1/4 minus 1/2. 4 minus 1/2, that's 8/2. 8, 7. That's 7/2. So then this would be 7/2, which, flip the second one and multiply, that would be 2/7. And so on. However, we still have to distribute this 1/2. So once we distribute the 1/2, what do we get? That would cancel out with that. So we have 1/3. Oh, that's what I have. Plus the 2's would cancel out there. 1/7. That's not what I have. That's not what I have. So this one cannot be the answer. So I just keep evaluating until I get the right answer. I mean, this, you won't have to write down as much. You won't have to explain it to anybody, so that's good. But that's how you do this. It's just getting comfortable with sigma notation. You do have to check more than just the first one. I checked the first one and they matched. And you can't say, oh, that means it's the right answer. No, you got to check a couple. They all have to match. But so this one doesn't work. Let's try out, well, I'm definitely not going to use that one, right? Because that means I'm only going to have 4 sums, 4, I don't even know what you call it, 4 items that I'm summing up. So it's definitely not this one, because I need to go all the way to 6. Definitely not that one, and I already checked. It's not that one. I'm going to check this just in case. I'll pause it and check this. Maybe you should try it. You should pause it and check it, and we'll see. I'm assuming this is the answer, but I just want to double check. So if you wanted to see it, there it is, and it indeed does work. So there you go. That's how you do that type of problem. Please, like, you didn't have to copy this down. Hopefully you didn't. Or if you did, that's great too. But please ask me questions if you don't understand this. Really, the idea is to get comfortable with sigma notation and to just also get comfortable with calculating or approximating area using rectangles. All right, I'm gonna stop this video. Go on to the next example. Again, you don't have to copy down the next one either.